Okay, so continuing from the previous video, we already have this code, right? Okay, so the previous step is to apply thresholding. Now, this is the thresholding that in the previous video, okay? Now, moving on to the next step, in this video, I want to talk about structuring element. And the structuring element is useful when we want to use morphological operations in OpenCV. So I will explain briefly about morphological operations first, and then I will explain why we need structuring element and how to use structuring element in OpenCV. So what is morphological operations, especially for OCR in OpenCV? So morphological operations are image processing techniques that manipulate the shape or structure of object in an image. And this is primarily applied to binary images, so black and white images that we have before. And the most common operations for OCR are dilation. It enlarges white objects by filling in small gaps, and this is useful for connecting broken parts of text. And then we have erosion. It shrinks white objects by erasing small irrelevant details, and it helps remove noise around text. And we have a combination of dilation and erosion. This is opening and closing. So opening is a process to remove small noise without altering the main object shape, and closing is the process that closes small gaps within objects. Okay, so I'll talk in details about these morphological operations in the next video, but today I want to focus more on structuring element. So why is cv2.getStructuringElement necessary? So cv2.getStructuringElement is the function name, okay? The function cv2.getStructuringElement is used to create the kernel or structuring element. And this acts as a template defining how morphological operations are applied. So the kernel determines the shape. We have three options: rectangular, elliptical, or cross of the processing area, and we have determines the size of the region influenced by the operation. Next, what is the relation to OCR? So the right kernel ensures that morphological operations focus on enhancing text areas, such as connecting fragmented letter or removing surrounding noise, that leading to more accurate OCR results. Without an appropriate kernel, morphological operations might yield suboptimal results, like overly smooth text or incomplete noise removal. Okay, now let's dive into the function itself. So this is cv2 that gets structuring element in OpenCV. So it used to create a structuring element, also known as kernel, which is essential for performing morphological operations like dilation, erosion, opening, and closing. And the structuring element defines the shape and size of the region of interest, or ROI, that the operation will affect. So this is the syntax. We use a parameter shape and parameter key size and anchor. So we have three parameters. First one is the shape. It specifies the shape of the structuring element, and we have three options: rectangular, elliptical, and cross. Next, parameter k size. This is a tuple. We specify the width and height that determines the size of the structuring element. For example, we use 5 by 5 to create a 5 by 5 kernel. And then anchor, this is optional. It specifies the anchor point within the kernel. Default is -1 and -1, means the anchor is at the center. So we usually just specify the shape and then the k size. That's it, okay? And the return value is actually a 2D numpy array containing the structuring element with binary values. 1 represents the area that will be processed, and 0 represents the area that will not affect the operation. And this is the common structuring element. For example, this is for size 5 by 5. This is for rectangular. This is for ellipse, and this is for cross shape. Okay. So Why is it important? So the structuring element determines how the morphological operation processes the image. The shape decides the pattern used for modifying pixels. For example, rectangular kernels are good for general operation, while elliptical kernels, smooth edges, and cross-shaped kernels are used for specific center-based operation. And then the size, this is influences the extent of the operation. So larger kernels have more significant effect on the image. Okay. So if you want to read in details, you can go to OpenCV documentation to read about the function here, cv2.getStructuringElement. And there are three options for shapes that we have, and the illustration for 2D NumPy array. Okay, so this is the function, you can read it here, and this is the shapes that three options that we have: rectangular, ellipse, and cross shape. Okay, and you can also see here, this is the structuring element. This is from morphological operation page, morphological transformation, and we can see this is the kernel, the rectangular, ellipse, and cross shape. Okay. Next, let's create a simple code and visualize the structuring element. So here's the code from the previous video, and here we use cv2 get structuring element. We use rectangular and using 15 by 15 size, and we have that as a kernel. And now this is the kernel if we use a rectangular shape. Okay, let's try this. Let's run this. So this is an array, a 2D NumPy array for a rectangular shape. Let's try with an ellipse shape. Okay, so this is the 2D NumPy array for ellipse shape. Okay, and then let's try the cross shape. And this is a 2D NumPy array for cross shape. Okay. Now let's try to visualize those three shapes using a single page for OCR. Here I'm using dilation, so cv2.dilate, so we can easily see the results. Okay, so first one, let's try the rectangular shape. Okay, so this is the result. This is for rectangular shape. Now let's try for second one is elliptical. Let's run this, and yeah, this is the elliptical. So it smooths the edges. This is elliptical. Lastly, let's try for cross shape. Let's run this, and yeah, this is a cross shape kernel. Okay, center based operation. Okay. So when performing OCR on an image like the one provided above, where text is dense and structure, the choice of kernel shape and size plays a critical role in preprocessing. Specifically, rectangular kernels are often the best choice for morphological operations, as the text appears block-like and aligned. So if I can recommend the kernel, so for kernel shape, we use rectangular kernel as it aligns well with the structured nature of the text blocks. For size, we use dilation. For dilation, we start with small kernel to bridge gaps between characters, lines of text. For erosion, we use small kernel to remove small noise around the text, and if texts are very close together, you can increase the kernel size, okay, to focus more on horizontal connections. So in conclusion, why we use cv2.getStructuringElement? So this function allows you to create a kernel tailored to the specific requirements of your text processing. So the shape dictates the pattern of the pixel selection, and the size, it determines the scale of the operations. Okay, so for dense text, a larger kernel helps connect components across larger gaps, while smaller kernel targets finer adjustments like noise removal. So this function is crucial because the structuring element directly affects how morphological operations like dilation and erosion process the image, making it a key step for optimizing OCR results. So okay, that's it for this video. Now you know how to use cv2.getStructuringElement to create a kernel, and in the next video I will explain more about morphological operation here. and applying the kernel for those operations. Okay, thank you.